Good morning, everybody. Welcome to another session of I Get It Live training. My name is James Keller. I'm the subject matter expert here for SolidWorks and a SolidWorks subject matter expert as well. And today we're going to be taking a look at an introduction to SolidWorks Mbd in SolidWorks 2018. So this is going to cover a few things I think we'll get over today. If you didn't know, MBD stands for Model-Based Definition. And in this session, I'm going to show you how to use a broad stroke of MBD. Definitely not all the details that are entailed, but going to go from beginning to end, showing you some DIM expert tools, so how to fully define a model in the DIM expert. Using annotations, then how to capture 3D views that represent that PMI or product manufacturing information there, and then how to publish those views out to a 3D PDF, which is a pretty neutral file format for sharing this type of data. It'll be opened in any PDF viewer. So moving on. Some specific things you'll learn is how to access and activate MBD. It's not shipped with default with every seat of SolidWorks, so you need to acquire a license to activate MBD and then unlock its full capabilities. I'll quickly touch that. You'll learn how to automatically attach dimensions. There's an auto dimension scheme tool in the DIM expert that will help you attach PMI, especially if you're not sure how to fully define a model or are not very well versed in geometric tolerancing and GD&T standards. So it's a pretty cool tool. And we'll again learn how to capture 3D views to represent all that PMI, much like you would traditional drawing views, except 3D views are dynamic, so you can, rotate them, zoom them, and inspect them a little bit better than 2D drawing views. So let's go ahead and jump right into SolidWorks here. SolidWorks 2018. I'm just going to hit R on my keyboard to bring up my recent files, and we'll go right into this caster wheel here. This is a pretty simple part. There's not a whole lot to it. It's a multi-body part. I've got two bodies up here, got a hub, and a tread. And we are going to fully define this in the DIM expert and go on from there. So starting off, you can see that I've got the SolidWorks Mbd command manager available to me here. It will be available when you have your license active and installed on your machine. So if I bring up my existing licenses, you can see that I've got SolidWorks Premium and SolidWorks Mbd Standard there. Now I know that SolidWorks is doing a subscription service now to some degree. I'm not exactly sure what the details are with that, so I'm not sure when and how Mbd is included in the newer versions of SolidWorks, but just be aware that you'll have to get a license there to get it going. So contact a reseller or go on to solidworks.com to figure out more details about how to get that done. Once it is active and installed, it's not like an add-in or anything. You don't need to go into the add-ins to activate it each time or anything like that. It'll just automatically start each time you run SolidWorks. So there's no extra step you need to take to make sure it's available to you after you install the license. Once you get the license installed, you'll have the command manager, MBD command manager available to you, along with the 3D views tab. And I think 3D views tab is available without MBD installed. It's just limited. You can't do some things. Like you can only publish out the e-drawings, and I think there's some limited features. So just so you're aware. Let's go ahead and take a look at this model to start. I'm going to go back to the Model tab before we jump into the 3D Views tab. Like I was saying, pretty simple, two solid bodies there. And got a few different configurations as well. We'll just go ahead and start in the 104 diameter but as you see, I can cycle through this, and we got two other smaller configurations as well. And as got a few display states down here showing solid and a transparent tread option. So all these will come into play throughout the this session here this morning. All right. So let's go ahead and get into the DIM Expert, which is right here, the DIM Expert Manager. There are a lot of cool tools available between the DIM Expert and the SolidWorks Mbd task or command manager here that will allow you to define your model. One of the most powerful ones is the Auto Dimension Scheme tool, and this will automatically attach PMI or product manufacturing information, which are basically these various annotations and callouts that define the model in 3D space. So I'm going to go ahead and activate that. You can activate it here on the Mbd Command Manager or from this little button right here in the DIM Expert Tree Property Manager, rather, excuse me. So we'll go ahead and activate that. And the first thing I need to do is define the settings for the part type. Well, it's not a prismatic part. In this case, it's created like a turned part. So I'm going to dimension it like a turned part. Tolerance type, I'm going to use plus and minus for this example, and not GD&T, geometric tolerancing. We'll get into that later with a few manual examples, but for now we're just going to stick with plus and minus. And there's no pattern to dimension in this model, so I'm just going to leave it as default there. Here are your datum references. The datums are the points of reference for all the measurements in 3D space. So the datums are what define your model's position or the reference points for measurements in 3D space. In this case, we only need to do two because it's kind of rotated parts, so it's symmetric in two different axial or two different planes there. So we only need to define a primary datum and a secondary datum for this one. Tertiary datum will just be over definition in this case. So we'll start with the primary datum. I do want to point out that none of the tolerance settings in this example today are specific to any kind of standards that I'm familiar with. I'm just using the SolidWorks default settings for tolerance standards. So I would not look at any of the actual numbers for tolerance data that we're using today and think that they're representative of any thing besides the SolidWorks standards. Just a side note for you. So starting off, I'm going to select this outer face here for my primary datum. You can see that when I select it, I get a little toolbox here that kind of helps me decide what type of geometry I want to select. It's only giving me the boss option in this case, so that's fine. Once I select it, you can see that I got a little right arrow there, right mouse click arrow. If I click that without moving my mouse away from the original selection area too far, if I move it away, see it goes away, it'll automatically jump to the secondary datum field. So that helps you from having to go back and forth from the graphics area and selecting these fields. So now that I'm in the secondary datum field, I'm going to pick this hub face, but I actually want the datum to measure from the center of this wheeled profile. So rather than measuring from this face, I want to measure from the center between both of these faces. So I'm going to use the create width feature option here. So having selected one face, I'll then go create width feature, and one face is already selected in my selection field here. I'll go ahead and select the opposite face there on the other side of the hub and click OK. And now the datum is defined by a width feature, meaning that it's going to be the center of the profile here, the middle of these two faces. So there we go. All our datums are defined for this simple model. Like I said, we just need two in this case. Next thing we need to define are the scope. So you can define all features and refine all those features by checking or unchecking the filters down here if you'd like, or you can choose selected features and pick on certain geometry in the graphics area to actually define. And that's all that it'll attach the dimensions for, is just the selected features. We'll go all features in this case, and go ahead and click OK. All right, when we do, you see that the model turns mostly green in this case. This green is just a graphical representation to let you know that those features are fully defined. So anything displaying in green right now is fully defined, meaning that as the definitions are currently applied, these surfaces and features are 100% definable. Yellow features, as in these surfaces right here, and they're actually on the other side of the wheel too, those are only partially defined, meaning they've got some of their definitions are there, but not 100%. So say maybe a profile tolerance isn't defined, or a position tolerance isn't defined 100%. So they're only got a size definition to them now, meaning that they're only partially defined. So this tool comes on immediately after clicking OK in the Auto Dimension tool, just so you can kind of get a good feedback of what's been defined and what hasn't. I'll go ahead and just toggle that off for now. Note that you can also tell what's been defined and what hasn't by the feature tree, just as in with sketches. Blue text with a negative suffix there indicates that these are undefined features. So you can see that the cylinder here, the highlights in the graphics area, was one of those yellow faces. So what we want to do is make sure that this is fully defined, and not only that it's fully defined, but that all these annotations that are currently created and that we will add to completely define it are displayed in a way that is clear and works for you. So you see all this stuff was automatically populated when I use the Auto Dimension Scheme tool. The first thing to do once you use the Auto Dimension Scheme tool is to kind of run through all the annotation views that were created. And here are the different annotation views. When I open the folder there, you can see all of them that were automatically created. Some of these will be populated and some of them may not. So it doesn't really matter. At this point, you can also see that these annotation views are in the Feature Manager design tree as well. So one of the best ways to start interrogating your views is to just right-click one and choose Activate and Reorient. This is going to reorient to that view and activate only the annotations that are assigned to that view. So we can see right now, here in the right view, nothing. No annotations were created for the right view. Activate and reorient to the back view. Looks like we've got a few annotations here, and they're linear expressions of, looks like fillets. So I don't think I want to use linear expressions for any of my diameter dimensions in this model, and I think that's how it attached them for every case. So I'm going to start by turning these linear expressions into diameter expressions by just selecting the relevant dimension there, going to the Leaders tab, and changing it from linear to diameter. And once I do, you can see it disappear from that view, and this is because it's automatically snapped to a different, more relevant annotation view. So I'm going to go ahead and make all these changes anywhere where I see a linear dimension. So anywhere where I see a linear diameter dimension anyway. So I'll go into the bottom. Looks like we got, oh, that's where those annotations I just created got just changed, got sent. So now you can see how they're expressed with diameter leaders. It looks like at the top, Activate and Reorient, is where the rest of these dimensions live. So we still got a few diameter dimensions down here that I want to go ahead and select and change over. And unfortunately, these are one of those things that just can't be done very easily by control selecting. if I control selected this and try to apply the same leader, like to say these three, it just doesn't work. It only works for the last one for some reason. The last one selected, the first one selected. So it's one of those things you just got to go and do manually. So just go ahead and move through these. See, sometimes I want to pick a new arrow style too. And there we are. It looks like we also automatically included a instance count for these two measurements right here, measuring from the datum out to the outer faces. I think because we have two bodies in this case, that's why it gave us an instance count. But for this purpose, we can go ahead and get rid of this instance count. So I'm just going to select the dimension and uncheck the instance count option here in the Property Manager to modify those dimensions. All right, and I'm kind of liking what we're seeing here, so I'll leave that top view as is. I'm going to go back through and see where my other dimensions that I just changed got put, and it looks like they got put on my front view. So I'm just going to kind of stretch out to reorganize here. Doesn't really matter exactly where things go as long as they're legible and clear. And you can see that the display for these dims can be a little funny. Like if I click out, you can see that the leader is running through some solid geometry there, and so it's kind of obscured a little bit. So this type of behavior is not unexpected. Now, also, you may notice just now when I rotated the model that all the other dimensions became visible. That's because once I did, this was no longer only showing the front assigned annotations. So activating and orienting is a good way to keep things from getting kind of jumbled. So you can see here that when I rotate the model, it already starts to look a little crazy here. I can grab and pull on dimensions through solid geometry, and we've got another dimension right here that I didn't notice. And my guess is that it is on the back orientation view. I hadn't gotten there yet. So, and there you have it, right there. So, no reason for this one to be on the back. You can do this with any annotation. Once it's selected, hit the tilde key. That's that little squiggly key underneath your escape key, and it will bring up the annotation views that exist that you can change that annotation view to. So right now we're in the back annotation. I'm just going to select the front annotation view to move that. So now you can see it disappear. I'm going to do a rebuild. That's Control Q or Control B on your keyboard to do a rebuild. You might find that you have to do that often to get these dimensions to display in a way that's more predictable. But all right, so now I think I've organized all the dimensions and annotations that were initially attached using the Auto Scheme tool. All right, so you can see here. But we still got to add more dimensions because there's still plenty of stuff that is not fully defined. And in fact, I think by changing some of these diameter dimensions to from linear, it may have actually opened some things up for it to be less defined. So we'll go back to the Show Tolerance status tool here, and yep. So now we've got even more yellow geometry. So we want to get all this yellow geometry to green. As an aside, another good way to view annotations is by using the Dynamic Annotations View command. So if you're just rotating the model in normal space instead of strictly using the Activate and Reorient options over here by right-clicking, with Dynamic Annotation Views selected, dimensions disappear unless you're rotating. So you can see how they kind of ghost. And now when I get close to a view with attached dimensions, they activate and they become active even when I let go of the mouse key the mouse wheel when I'm scrolling here. So now I could go close to the top view, and there we go. Now the top views become active. So this dynamic annotation views tool is pretty powerful in that respect, especially when you have a lot of overlapping PMI that kind of jumbles up the model display there. So just another tool that might help you organize things. So I'm going to go back to a 3-point view here. Isometric doesn't really matter. Turn dynamic annotation views off so I can see everything that's there. And we need to start by defining the rest of this geometry that's not fully defined. So let's first make sure that we don't have any superfluous features here in the tree. Now, because this is a multi-body part, I think we've got a boss here. You can see it highlighted in the graphics area, and a cylinder here that are basically, that's not a cylinder, this boss, maybe a simple hole. All right. I know there's another, there we go. So that simple hole and this boss here are basically the same geometry. So we can get one of them. We can get rid of one of them. We don't need to dimension them twice. So I'm going to go ahead and delete the boss feature. I could have deleted the simple hole just as easily. When I do that, we'll double check. Nothing's changed. Everything's still just as defined as it was before. Just gives us one less feature to worry about having to define. Some of the problems that this model is having fully defining that geometry is there are no datums. When you use plus and minus tolerancing, datums don't come into play. So let's go ahead and add some datums to give the rest of these references or dimensions a reference point. So I'm just going to go to the datum command up here, and I'm just going to mark the datums that I defined using the auto dimension scheme tool. So I'm just going to click on the same datum definition that I did for the tool, and once I do, you can see that the datum automatically attaches to that diameter dimension down here, which is exactly what you want it to do. So that's great. Now that's attached there, and again, I went forward to the next label, B label. I started off with A, automatically went to B. And I'm going to click on this face of the width feature, and it knows that that's part of a width feature, and again snaps to that width feature over here. We don't need a C datum in this case, so I'm just going to go ahead and click OK, and just reorganize things a little bit so I can see them easier in the graphics area. All right, so now we have some datums. Hadn't really changed our definitions yet. So let's continue going on down the tree and look at what we got here. So this cylinder and this boss and this boss and this opposite cylinder here, I'm going to go ahead and do two different options here to add PMI to these guys. So I'm just going to go ahead and delete. Let's start with these cylinders. I'm going to go ahead and Control delete these two cylinders. I'm going to redefine them manually in a more consolidated fashion here. So I'm just going to delete on my keyboard, say yes. Now you can see that when I do the show tolerance tool, that geometry is completely the model color now. It's not even yellow, so meaning it's not even partially defined. I got to go in and fully define that now. I'm just going to go ahead and use a size dimension here from the SolidWorks Mbd Command Manager, and I'm going to select on my first cylindrical face there, but in the pop-up menu, I'm going to choose Create Compound Cylinder and go select this other face to consolidate both those features into one dimension here, and then I'll place the dimension. All right, now you can see that that dimension was placed on the back side of the model. So as an aside, I could take this little square anchor point and drag it to the geometry on the front if I wanted to change the position of that call out. So now I've got everything kind of here in the front. I also want to ensure that that was added to the front annotation, and it was. There we go. You can see it there in the front annotation. Go back. And I now need to fully define that feature. So again, we're back to yellow geometry. What it needs is a position geometric reference to fully define it, because it knows its size, it just doesn't know where it is in respect to the datums on the model. So I can go ahead and select the dimension, click geometric tolerance up here to attach a geometric tolerance to that dimension, and we'll start by selecting a position symbol. And you can see that this tool gives you feedback as you're going. Oh, okay, it needs a primary reference for that symbol. So now I can go in and just type in A, and we've got no more errors down here, and we can see that it actually pops up in the graphics area. So I'm pretty confident that that is going to apply. We only need to define it in respect to the A datum in this case. I could go and add a B datum. It's not necessary in this situation, so I'm just going to keep it at A and say OK. And now you can see the geometric data, tolerance data was added to that dimension. And lo and behold, when I go back, you can see that those two faces are now fully defined. I'm going to do something similar with these bosses, except in this case, I'm going to delete them. Yes to all. And I'm going to create a pattern feature out of them, again, to consolidate those two similar dimensioned faces into one feature. So I'm not going to go into the three different options here, but SOLIDWORKS seems to choose the best option for you automatically when you select the geometry in the window that you want to pattern. In this case, it created a manual pattern. I'll click OK, and then we have this boss pattern down here in the feature tree. Again, we'll do another size dimension. Just click on one of those faces. Whoops, didn't really. Size dimension here. Make sure I'm highlighting the face, and then click to attach the geometry. In this case, we got a call out, which is good. And if I go to show tolerance, see that we need to add something more to it. So again, let's highlight it, select geometric tolerance, and I think we need another position here. So position, again, primary datum A, in relation to primary datum A. All right, and we're moving through here. You can see now that stuff is green. So we're going to continue on. I'm going to go ahead and just continue adding position tolerances in some of these cases. For this simple hole, for example, for the axle, I don't need to replace any dimensions. I'll just use what the dim expert created for us. Say OK. And I can keep on checking A using this show tolerance status tool, or B by looking at the options down here. So we've got this simple hole. Let's go ahead and do that next. I can grab the diameter by selecting a tree. Say if there was too much PMI, to notice which diameter was attached to that simple hole. And we'll just keep on going and adding positions in this case. All right, so things are beginning to become fully defined here. Now it looks like I just got some fillet patterns that I need to fully define. They currently have a radius dimension attached to them. So I'm just going to select that radius dimension for the first fillet. And I believe in this case, I am not a GD&T expert by any means, but I think that if we apply a profile surface symbol, that's what it's looking for. And it may need a reference to both the A and B datums in this case. And if I say OK, the tolerance is applied effectively there. You can see if I rotate the model, there we go. So instead of a position, we needed a profile tolerance in this case. And we could see that now that is fully defined. No more blue text there. And we've got one more radius dimension right here. We'll go ahead and do the same with it to wrap up the definitions of this wheel. And now you can see, I mean, this is taking a little bit of time just to, even with the automatic dimension scheme command helping, this is still taking quite a bit of time for me to dimension, fully dimension this fairly simple model. So utilizing that auto dimension command can definitely save you a lot of heartache and time when you're trying to fully define your model. And so if we go to show tolerance, there we are, 100% green. All the geometry is defined. So as it stands, this configuration of this model is fully definable. And we see that we've got no blue text here and no negative marks indicating anything there that needs to be done. So to finish up with this configuration still active, I'm going to go ahead and activate and reorient to all of these annotation views one more time to make sure that everything's kind of organized how I'd like it, because the next step we're going to do is we're going to go capture some 3D views. So we're going to capture views representing these callouts. See, in this case, I want to move from this dot leader to arrow leader. Doesn't really matter how this stuff is organized, just in a way that's clearly presented. Maybe I can move this datum up there instead of down. Makes things a little bit easier. All right, so that's the front view. I like the way that looks. We'll go ahead and activate and reorient to the bottom view. And this shows my datum and the fillet callouts in this case. I'm going to bring this B datum up to the top here so it doesn't get in the way of this callout. And we can see here that I don't really like the way that this is being attached here, because this fillet that it's detailing is obscured. So in this case, I just want to activate the section tool real quick just to make sure that everything's attached and looking kind of how I want it, because when I capture the 3D view eventually, I'm going to capture it as a section view. So, all right, that looks good on the bottom view. Let's go ahead and activate and reorient to the top view. We've got those guys right there. Now again, since top and bottom view show essentially the same profiles, let's go ahead and move this bottom view information to the top view. So again, I'm going to select the annotation, click the tilde key, and choose top from the menu. I'm going to do that for all three of these. Top. And even my datum call out here. Top. All right. I'll go ahead and activate and reorient and get things looking how I wanted them to. And so you can see how that just jumped on me, that dimension. That's when you hit rebuild to kind of help organize things here. I'm going to go ahead and move all of these guys over to the right here. So I can keep these dimensions on the left. It looks like that's going to be fine there for when I do my section view. All right, there we are. So now, one last check of everything. We've got an empty bottom view, a front view, empty back view, and an empty right view. Let's go ahead and activate and orient to the front. I could, if I want, delete these empty views. Doesn't really get me anything, it just cleans up the tree. But just so you know, that could be something that might make things a little bit more easy for you as you go. In this case, maybe I will. I'll go ahead and delete the bottom view and that right view. I don't think we have anything in the back view either. So activate and reorient to my front view and delete the back view. Notes area is created by default when we use this command. The notes area is a pretty cool annotation space because it allows you to put anything flat to the screen as long as it is not attached to the model. So if I were to go in and create a note in this case, note, okay, make sure we don't have that extra one in there. I could assign this note using the tilde key menu to the notes area. It's hidden right now, but if we show, now that note will stay flat to the screen no matter what I do with the model. So just as an aside there for the notes area of your annotation, pretty neat. I'm going to go ahead and delete that and then rehide the notes area. Unassigned items are just things that don't, for one reason, don't get assigned to any of the other annotation views you have. And in this case, it is empty. So nothing that I have missed there. All right, so now we've got pretty much a fully defined model, all the annotation views that we need, and everything's organized well for each view. So I'm going to go ahead and rebuild and save my model, just as a good practice. And let's go address these other configurations. As you might have guessed, as soon as I activate another configuration, all the PMI disappears. Nothing's in the dim expert tree for either one of these configurations. So you can spend the time going back and redefining the PMI for these configurations as you just saw, or in the dim expert property manager, there's this little tool right here, copy scheme. It's these dual crosshairs. If I click copy scheme, it's going to ask me to name my new scheme. I'll just call it scheme 2 in this case, and then it's going to ask you for a source configuration. The 104 diameter configuration is where all that PMI is attached. So I'll just say OK, and voila, there we go. Now, in this case, I'm not sure why this is happening. The geometric tolerance callouts look like they've lost some type of reference, which is why they're displaying in brown here. Although all the definition, all the geometry is still fully defined and correctly represented here. So in this specific case, even if I go and select that tolerance for any one of these situations and delete it, for example, I can go back and add exactly the same tolerance as I did before, and it displays correctly. So I'm not sure exactly where the disparate references are for these guys, but in any case, whether they display in pink or brown, it seems to be fully defining the model regardless. So it might be good measure if you have these, when you copy a scheme from one configuration to another, to change those situations if they occur in your instance. But like a right click or something like that does not really seem to give me any indication of how I can redefine that reference that seems to have been lost. But in any case, it's still fully defining the model. So just food for thought there, guys. I'm not going to spend the time to go back and redefine all these references for each one of these configurations. I'm just going to leave the brown dimensions as is and go ahead and go into the 80 millimeter configuration, and again copy over, we'll call this scheme 3, copy over from the original, and there we are. Everything's fully defined. So you can see how quickly using the copy dimension scheme tool, I was able to fully define the other two configurations based on the first configuration we used, which is where we're going to live for the majority of this exercise. All right, so that's most of the DIM expert part. That's a good portion of what you'll need to do for MBD is defining your model with all these dimensions and annotations. And you've seen kind of briefly how you can use the auto dimension scheme in concert with some of these tools to do so. One of the things I'd also like to show is, say, this. Let's use this guy right here in the front view. The location of this axle hole. You may have noticed that even though it added a geometric tolerance to it and it's fully defined, you don't actually see any location dimensions here. Well, if you want to show those, you can automatically insert them for any item that has a position annotation. So anything with one of these guys, position annotation. So in this case, if I wanted to, trying to find my axle hole, here it is. If I wanted to insert basic dimensions, these are these basic location dimensions. These are dimensions that don't include tonsing data. All you have to do is right-click on the position item in the tree and select Recreate Basic Dim. And this works for any position item. So if I do that, it recreated the location dimensions for this guy. And if I go and probably put them in a different view, activate, looks like I'm not seeing it here. Let's try that again for something different. Let's try that guy. So we have a position here, right click, recreate basic dims. It's not inserting dimensions like I've seen in the past here. Let's go ahead and try this one more time. One way to show all the position items in the tree is you could choose Show Flat Tree or Show Annotation Based Tree from the right-click menu there and Tree Display. That way you can kind of see all the position options here in one place. Maybe let's try this guy, Recreate Basic Dims. It looks like maybe because of the nature of my model here, it's not showing these basic dims whenever I select them. But what they look like is just basically a regular dimension with a box around it and no tolerance data. That's just to kind of give you a general location of a feature. But position items do not show them by default. You have to right-click them and choose the Recreate Basic Dim to insert them. And I think it's the nature of this turn part that's why they're not showing up. So just another aside for you. All right, so I think this model is pretty much ready to begin capturing 3D views for. So I will go ahead and access my 3D Views tab down here. This is where all the captured 3D views of your model will live. And it's good practice to go ahead and just capture 3D views of your annotation views, views that have active annotations in it. So in this case, maybe it's my graphics card or something, but you can see as I like highlight some of these callouts, the geometry will show as visible all the way to the edge or kind of get obscured. So I like to kind of like highlight them all to do the best to show them and then capture the 3D view. I like the way this 3D view looks. Maybe reorganize things a little bit, make sure it's zoomed in as good as it can, and I'm just going to go ahead and click the Capture 3D View button down here to get my first 3D view. First thing I'm prompted for is 3D view name. I'll go ahead and leave this front. That's fine. I'll just name it front of wheel. It's always good practice to rename things appropriately. We're going to live in this 104 diameter configuration with a solid display state, and I only want to include the annotations in the front view. So I'm going to unselect the top view annotations there. And I'm going to click OK. And now that view is added. So no matter how I move the model or interrogate it, I can always double click this 3D view to go back to that. And when I do, you can see that also all the other annotation views are hidden automatically because I just selected that front view to be shown. If I go show this one and unassigned items, you can see when I double click this, they automatically were hidden again. So be sure that you define your 3D views carefully so that they behave as expected. I'll go ahead and go to my top view now by activating and reorienting. I'm going to zoom in nice and tight so I get all the information clearly. Everything's looking how I'd like. So I'll go ahead and capture this view. This time, just making sure that the top's selected with the default selections. All right. So there we go. There's both the views that capture all the PMI of my model. And I could just stop here if I wanted, but I'm going to capture some more stuff. So like I said before, I wanted to show a section view to show this call out a little bit more clearly. So I'll go ahead and leave the top view oriented and go ahead and create that section view. Whoops. We want to flip that plane. There we go. And now we can see that that call out is pointing to geometry that is more noticeable. And in fact, I could even go in and pretty sure, thought I could hide individual annotations. If I wanted to, I could take this dimension and put it in a new annotation view by itself and have it just call out these details without all the other superfluous stuff. But don't need to do that in this case. So I'm just going to go ahead and keep this and do create or capture new 3D view. Looks like I had some funny display stuff happen there. I don't think that actually got captured. I'm going to call this section AA, making sure we're only doing the top annotations. I just double click it to make sure. Yeah, okay. See. All right. I can see now the difference between those two. So let's say, oh, you know what? I decided I really don't want these annotations here. I do just want to show these two annotations in this section view. Let's go ahead and go insert annotation view to create an annotation view that wasn't created automatically by the Auto Dimension Scheme tool. This is going to be parallel to the top view. So I'll go ahead and just select top right there. And it gives me a plane to make sure I know that my view orientation is correct. I'll go next. It will automatically let me select annotations to move to this view from the graphics area. So I'm going to go ahead and do that. I'm going to select this guy and this guy. I'm not sure here. We got everything. Uh-oh. SOLIDWORKS was crashing on me. I apologize, folks. Just give me 1 second. I'll get everything back up here. I just had a crash. You could basically get the idea of what I was trying to do there, creating a new annotation view to put those different annotations in, so only they were expressed in the view that I captured. So luckily I did a save before. I'll activate and reorient, recapture those views real quick. Again, just the top. reorient, capture this guy, just the top. Do our section view. Go ahead and save in case we get another crash real quick, and then insert annotation view based on the top view. In this case, just in case we get another mess up, I'm not going to try to select the annotations to move in this point. I'm just going to go ahead and skip the second step there and just click OK to create the new view. So you can see that I've got top and top one. Top one is what I just created, and top is my original view. So let's go ahead and change this view to section. I'll activate and reorient to that view, and then Control select all the data here. Using my tilde key, move that over to my new view. And make sure that it's hidden in the top view. And we're going to have to do a little maneuvering here. But once I get my section up again, okay, we can capture the new view and call it section A. Geez. There we go. All right. So you can see how you can start to capture these 3D views that are eventually going to be exported out to this 3D PDF that we're going to be creating here shortly. I'm going to zoom in on this view a little bit more, and I'm going to recapture it by right-clicking on that view and selecting Recapture View. And all I got to do is just, it's like a edit feature. So basically, Recapture View is basically the same thing as edit feature for other SOLIDWORKS features that you're used to dealing with. It'd be similar to using an edit feature command. It just allows you to jump back in and redefine the view. And let's go ahead and do a few more views to show some more annotations and the different size options. So I'm going to go ahead and maneuver my model to an isometric view. We'll get rid of the section view, and I will just go ahead and activate and not reorient to my front view and choose to hide. Let's actually activate the unassigned items. That way I can hide everything else. So now you can see, now that I'm on unassigned items, I have the ability to hide the other annotations that exist, because I want to create another annotation using a reference dimension. So I'm just going to use the Smart Dimension tool here and choose reference dimension. These dimensions live separately from Dim Expert dimensions. So I'm going to go ahead and attach that. And this is basically just to show the diameter of this wheel. So I can go in here and uncheck Show Dim Expert Annotations. And I can make sure that this is in the Unassigned Items annotation there by doing the right tilde hotkey menu there. So I've got this new annotation and an annotation view that I want. Now I am ready to capture this view. So I think this shows pretty good the dimension of the diameter of this wheel. So I'm going to go ahead and capture new 3D view. not selecting any of the options here because it's unassigned, and using this 104th configuration, we'll go ahead and capture. Now, without moving the model, I'm going to go ahead and capture another one and just select the next configuration. You can see that the reference dimension automatically updates to correctly reflect the new size. I'll go ahead and say OK. We'll go ahead and capture a third one to show the 80 diameter. All right, so now you can see I've got a lot of 3D views here now in my 3D views pane, all of which combine together to accurately depict the different option this wheel comes in. And to fully define it in this case, I probably want to continue to do these front and top views for each configuration as well. I'm not going to go through that in this situation, but know that you can do such a thing, and it's easy to rename views just like anything else. I can go in there and do a slow double click and rename a view, no problem. I can also choose different sort orders here. So by default, they're ordered in order history that they were created, but you can order them by name. I like to do a custom sort order, and then you can just drag the views individually however you'd like. So you can see that there we go. Now we have full capability of how these views are created. All right, so now that we've fully defined our model and captured all of our PMI and easy to read 3D views, and again, I can activate a view and then look at it any way I want and always snap back to that view just by double clicking. Let's go ahead and update one of these views just to show one more thing. I'm going to go ahead and right click and recapture view. And in this situation, I want to show the transparent tread. I've got a display state set up in this model, transparent tread. So you can see that not only can you capture configurations, but different display states as well. And in this case, I did not link my display states to the configurations, so those display states are available for each configuration if I want. There we go. So that's capturing 3D views. I'm going to go ahead and rebuild and save. I'm using keyboard keys to do that. That's Control Q to do a solid rebuild, and then Control S to save. So my model's ready to be produced to a 3D PDF. This is the format that will be shared with your design collaborators or manufacturers to actually communicate the design. So this can be done pretty easily from the Mbd command manager by choosing Publish to 3D PDF here, or you can also do it down here by hitting the Publish to 3D PDF button in the 3D Views pane. So we'll go ahead and start that. First thing to do is, just like with drawings, choose your template. And in this case, I've got a custom template that I've created. I'm not going to go into it here, but in the course that I'll point out here shortly, you can also edit your 3D PDFs to work specifically for your company or needs. So in this case, I've added a cool little paper background. I've changed the logo, changed the fields here a little bit, but we won't be getting into that right now. Do get into those details in the course, though. Next thing to do is to select whether or not you want to include any primary views in addition to the 3D views you've captured down here. So in this case, it's a simple model. I don't really need to include any more primary views to communicate the model, so I'm just going to keep those unselected for this case. As far as the rest of the views down here are concerned, I think I want to show pretty much all of them. So I'm going to choose Control. I'm going to hold down Control and select my View 4, my 3D View 5, my 3D View 6, my front view, top of wheel, and section AA. The only thing I haven't selected is the current model view. Accuracy, we keep that maximum in this case. You can also choose to choose which view is in an independent viewport. If that exists in this template, it does not. There's only one main viewport, so this is not applicable for this case. You can learn more about this in the course. And you also have the option to attach files. So if I wanted to attach, say, this part document to the 3D PDF, I could do that as well. And a checkbox allows you to automatically create a step file along with the 3D PDF as well. A step file being a CAD neutral format that almost any CAD program can read, at least as solid geometry. The features won't come through and stuff like that. Go ahead and click Next. This is where I'm going to edit the output fields. Those were those text fields that you saw in my template editor there briefly. They are linked to certain model properties that I have defined. In this case, it's showing some duplicates, like two-part numbers here, and a couple other things. I'm not exactly sure why that is in this case, but they don't get duplicated in the produced part. So funny SOLIDWORKS behavior there. We got a date, we got a revision, got to select here what material to apply, so that's already defined. Got a designer defined here, in this case Cosmos, and we've got a comment section that doesn't have any specific properties attached to it, but see this white field here, everything else is grayed out. This indicates that, oh, it wants you to actually enter in manual text here. So you could say review upon initial open or something like that as a comment. So that will pop up in the text field there on my 3D PDF when I produce. Designer, I could, looks like it's also, I've already defined it here for Cosmos, but it's not great. Also enter it manually here if I wanted. I'm not going to in this case. So now I've got all my custom properties defined as I'd like. Go ahead and close that model or that modal and click OK to produce my 3D PDF. It's going to ask me where I want to put it. In this case, I think I've already got an instance of it. I'm just going to overwrite here. We'll overwrite that. And SOLIDWORKS thinks for a little bit. I also had the option check there in the Save dialog, Open PDF after saving. So it'll automatically open it here for me. And here we are. So I got a 3D PDF. We've got the description, in this case, the part number, a date, a designed by field, the notes field, which we can go into more in the class, but this is basically an area for anybody who reviews this 3D PDF to make a note. Yeah, I can put that note in there if I want, or you know, model looks good. And if I save this out, well, that's odd. Looks like it did 2 tabs on me there, 2 pages. I must have defined a second tab and not known it. In this case, if I were to save it out, anybody who opens this file in the future will have access to these notes and can review them, modify them, see them, the whole 9. You'd see that 3D View 4 is here in the main display, and I can click to drag it, manipulate it, rotate it as required. Some of these things show up as planned, some of them don't. You can see that my transparent view there just ended up showing up completely transparent. No worries, that can be changed in model display sometimes. In this case, it can't. So 3D views aren't 100%, or 3D PDFs aren't 100% sometimes. You can see this case, this is less than optimal, probably because I had a white material defined for this hub, and then the other thing was transparent, so it's not showing up. Maybe I can show solid outline. That doesn't seem to do anything either. You can also see that the colors aren't necessarily coming through, but still, because it's such a lightweight format, it's still describing the model adequately here. You see it's definitely all the PMIs coming through. One thing to note that in SolidWorks, when you rotated the model more than 180 degrees from its initial PMI view, the PMI would rotate with it. In this case, it doesn't once you're in the 3D PDF, so that is something that's worth noting. Make sure that you build in your design intent with that in mind when you're creating and capturing 3D views. But you can see that I have a lot of different ways I can interrogate even each individual view up here. I can do a section view if I want and define that section however I need. I can, looks like I changed the background color there. I can change the lighting on the model. You can see how, so I scroll through, change the display there. Can also change the transparency or the display state of the model. So you have some options here. We'll go ahead and do solid outline again. I can even look at it in a perspective view if I'd like. There is a tree option that you can activate, and that basically just gives you access to the different views, much like you would down in the views pane, as well as different options here. I could uncheck that the 104 configuration, for example, and show the 92 if I want from here. So you've got a lot of different display options here in the model tree. By left here, it shows anything that may be cropped off by the ribbon down here. And if I hit the play button, I can automatically cycle through the existing views. So you can see how it's doing that automatically. I can just pause if I want to stop that. So there we have it. In a nutshell, that is 3D PDFs and how they can be used with your model PMI to communicate designs. So that's our look at SolidWorks Mbd today. I know it wasn't a whole lot. There's a lot more to cover, which can be seen in our course. I'm going to go ahead and close out this 3D PDF without saving. Go back to our model. This has just been a kind of a quick overview of what SolidWorks Mbd can do for you, and you can see how little we actually covered in more than an hour this morning. So there's a lot to learn, and it's pretty powerful stuff, especially if your design collaborators and manufacturers do not are moving away from traditional drawings, paper drawings. It's always best if you can share a native SolidWorks file with your manufacturer. So if they have the ability to review SolidWorks files, of course, just send them the file. That's the best way. But in lots of ways, lots of situations, that just isn't the case, especially when you have a lot of collaborators for a single design. So these 3D PDFs are definitely a powerful tool to share design data. So that being said, we'll go ahead and answer any questions that I can. I'll do my best to answer any relevant questions here expediently. And if not, if I don't get to you or you weren't mentioned, or if you come up with, if you have any questions that you think of after we end today, I'll show my email again so you can go ahead and email me that question. All right, so let's see here. I'm going through what we have so far. Pardon me while I do a little reading. Okay, and I'm only going to really, field questions that are relevant in this case. So there are a couple things here I think I can address in emails. So we got one: how to import SolidWorks, how to import views from MBD to drawing, and vice versa. That's a good question. So let's go ahead and jump in here. I mean, we did spend all this time setting up PMI, these dimensions. What if we did want to create a drawing? I mean, it would be it'd be a shame if we couldn't just reuse this data that we created in the drawing and we had to go back and redimension in a drawing. You don't have to do that. You can use it. So we'll go ahead and do a make drawing from part assembly here, just so I can kind of illustrate. We'll just use the A landscape. And we've got import annotations options here in the view palette. So if I check import annotations and check dim expert annotations, and then maybe any other annotations you might have that are relevant, they automatically import. So I can just drag the view over, and voila, there they go. And they're already organized how I organized them in the view as well, for the most part. I might have to do a little reorganization. If I go ahead and drop, I guess in this case it would be a top view. That's what we want. So maybe the wrong template to use in this case, but if I drag my top view over and stamp it there, again, I did not select. I'll go ahead and delete that view. Pardon me, got a confirmation window that was covered there. Yes, I do want to delete that. We'll go back, top view, dim expert annotations. That was where my, maybe, oh, top of wheel. That's where we go. All right, and there are those other annotations. So it's that simple. The annotations are always attached to the model, and you just have to make sure that they're used when importing the views. And you can also attach them after the fact once the views are imported. So hopefully that answers your question there about how to import views from MBD to drawings and vice versa. If you were to create regular annotations in a drawing and were to try to use those in MBD, if I go back to the model here, by hitting Control-Tab, I can switch between open documents. I could show other annotations by right-clicking the annotations folder and showing the annotations, like say if I wanted to show feature annotations, for example, I could do that, and any feature annotations or other annotations that were attached to the wheel would display, and including annotations that you created in a drawing. So that's how you go back and forth between drawings and MBD. All right. Okay. So I think that's going to cover the relevant questions for today. I'll try. There are a few other questions I see here that may not 100% pertain to the data, so I'll see if I can answer those offline through email. We do have your email information, so Marshall, we'll see if I can get back to you. Looks like vice versa. You skipped vice versa. That's what I meant by that is that if you're in a drawing, I think I maybe wasn't clear enough. If I'm in a drawing here and I don't want to show these dimensions. Let's say I just go in and delete them here, and let's say I'm detailing this like I would a normal drawing. I attach this radius dimension there. If I go back to my model, I believe that annotation will be visible if I want it to be. Showing all my annotations here. Yeah, so maybe the vice versa option there is not as clear cut as I thought it was. Because that annotation I just selected, I would assume would be visible here. And since I have all of my annotation options checked to be visible. So there might be something I'm missing here as far as the vice versa. Yeah. So sorry about that. Might be something that you can do, export this annotation to other views or something like that. But it looks like in this case, I'm not able to answer your question 100% right now anyway. So I'll do some more research today and follow up with you on your email there. All right. I think that pretty much covers the questions for today. I hope that you guys had a chance to learn a little bit about MBD, and hopefully it interests you enough to go in and take the course. Maybe sign up for SolidWorks and try out our courses on SolidWorks. We just did the MBD and DIM Expert one. Amongst other things that you'll learn in this course are specialized PMI applications, meaning it shows specifically considerations to think of when you're adding PMI to sheet metal parts, weldment structures, and like mold cavities for drafted faces. So there's some things to consider when adding PMI to those types of models. Goes over those use cases. We show you how to capture 3D views for assemblies. Typically, PMI isn't as detailed or detailed at all in assembly 3D assembly views. Basically, they're just there to show how components fit together and relate to one another. So that's a little different than what we showed today. Customizing 3D templates. You saw that I had a custom 3D template there from my 3D PDF. In the course, we go over how to actually create those customizations. And producing e-drawings. So we go over not only producing 3D PDFs, but e-drawings files as well using MBD. And in my experience, e-drawings are a little bit more richer of an experience than 3D PDFs, and can do some things that mirror the actual SolidWorks environment a little bit more closely. So that's a pretty powerful tool. Feel free to visit mygetit.com to see our full list of available courses, including all of our SolidWorks content. Hopefully there's something there that strikes your fancy, and if you're already an iGetIt member, please go in and check out the course here to learn more about MBD. There's a workshop in there too, so you can follow along and do some practices by yourself. So good stuff. Again, my name is James Keller. I'm the Instructional Design and Content Quality Manager here at iGetIt and a certified subject matter expert, SolidWorks subject matter expert. So please, if you have any other questions that pop in your head related to this topic, feel free to send me an email about it, and I'll do my best to answer. As far as getting your drawing dimensions into actual model annotations there, I'll do my best and to figure out that answer and get back to you later on today, sir. So that being said, want to thank you guys for joining us today, and enjoy the rest of your afternoon. And we'll see you next time for another session of iGetIt Live. Thank you.